Next up in the world of quadratic functions, we're going to talk about the concept of zeros. Zeros might also be referred to as the x-intercept, the places where the parabola touches the x-axis. So if I draw a makeshift coordinate plane here, it's important to note that a parabola may have two zeros, one zero, or no zeros at all. A parabola that hits the x-axis twice, like this one, is said to have two zeros. If it only hits it once, say this one for example, it's said to have one zero. Just one place it touches the x-axis. And then some parabolas don't touch the x-axis at all, like this one. This is said to have no zeros. The axis of symmetry is an imaginary vertical line that cuts the parabola into two perfect halves. So another makeshift coordinate plane here. I'm going to actually make some marks for the x-axis. And suppose I had an upward opening parabola like this. The axis of symmetry is not really there, we just have to imagine it. But if we were to draw a vertical line that went right through the vertex and cut this parabola into perfect halves, that's what's known as the axis of symmetry. It will always be the x value of your vertex. One of the assignments I gave out here, we can kind of see a few of them. This one, for example. We can see that this parabola has two zeros. You may not be able to see on the video from here, but that's located at -5 and -3. And its axis of symmetry, the imaginary line that would cut it into perfect halves, goes right through where x is -4. So two zeros at -5 and -3, and an axis of symmetry at -4. If you're ever asked to find the vertex from an equation, suppose this was your equation. You first have to find the axis of symmetry using the formula x equals -b divided by 2a. As long as y is by itself, a is the number that's in front of x squared, b is the number that's in front of x, and c is this constant out here without an x. So if I were to plug it into the formula, my b value is 8. My a value, if I don't see a coefficient, I understand is a positive 1. At the top I end up with -8. At the bottom 2 times 1 is 2. -8 divided by positive 2 makes -4. So I have found the x value of the vertex. To find the y value, I need to go back to the original function and take my newfound x and plug it in anywhere I see an x in the equation. And then simplify to find my y. -4 to the second power is a positive 16. Positive 8 times -4 is -32, and then our plus 12. 16 minus 32 is a -16, and then plus 12 we would end up with a -4. So the vertex of this particular parabola is located at -4, -4. So if you can imagine that, -4 would be located here. This parabola I know would be opening upward since my a value is something positive. So it's going to look something like that.